Welcome to a new episode of Tech Fabric, in which we will discuss resilience in networking. To do this, we will use some example in how IP Fabric can help us to highlight a situation where the good practices for resilience are not being validated and help us to remediate to this problem before a network failure occurs. I'm Lisa Vaccarino and I'm part of the solution architect at IP Fabric. And today I will introduce you to some useful features in the platform. We will start with a definition of resilience and then the resilience in networking. And then we move to some example internal in the platform. With the definition of resilience, we can say that it is a property of the material to resist to the shock without breaking, and is also the capacity to recover quickly from difficulties. Is the ability to resist and react in face of difficulties and negative events. And is the rate in which a community returns to this initial state after being subjected to any disturbance. And like last one is the ability of a substance to spring back into different shape. So we can see that in all of those definitions, we can have a common idea of adaptation that give a resilience the meaning to be adapted to any working field. And it is because it's giving us an idea of a promise that we can be able to fall without getting hurt. We are moving to the resilience in networking. And we can say that the network infrastructure is the base of the several business functions. And the design and the integration of the new development must ensure the resilience of the entire network. We can say that different network outage needs to have a minimal impact on the operation for the business service. We can imagine if a website for e-commerce can crash, or a call between manager in the company have a problem, the impact could be very, very high in the business. So we would like to prevent all these kinds of event and be sure that we are not facing to security issue like data loss, for example. In IP Fabric, we use the intent check that are already in the platform and support us to validate the state of the network as expected in our best practice. This will be validated every time at each discovery that is completed to the network and give an up-to-date picture of the total situation of the network, the status of each device, and we can compare the status to the what we expect in our best practices. Is exactly through this intent check that we can have a look to different example on to see how IP Fabric can support us to verify if our network is resilient and adapt to the changes. Example that we will have a look is for the single point of failure that could be present in our infrastructure. We say that the network must be able to accommodate any kind of problem and to assure the constant connectivity between the different devices and the different area of our network. But in the day-to-day reality, there are many different teams involved for the design, for the configuration, and for the maintenance of each single area and each single device. And we cannot guarantee that the principle and the best practice that was at the base of our design could be operational in practice in the everyday. We move to the platform and we can see how IP Fabric can support us to identify this possible single point of failure. We open the part of the diagram and we select one of the sites of our infrastructure. Here we can see all the interconnection between different devices. We move to the check that is already built in the platform and we select the one for the single point of failure. That in this specific site is highlighting this device that has only one connection to the other side. So probably this one could be a risk point to have just one interconnection to the other side. If we open the detail of this specific device, we can see that in the interface we have the detail of layer 1 and layer 2 state, and we have interconnection that are up, but we have also some interconnection that is down, and is exactly the one that is connecting to the firewall. We have also another check that is already in the platform that highlight the not redundant link. So if we move to this other one, we can see here in this part of the design that there is only one link that interconnects this side with this other. And with the drill down to this other side, you can see that there are several firewalls that has only one interconnection. And if for any reason this interconnection will be down, we lost the connectivity to this specific device and probably to the external site or our network. So with this check, it's always possible to view on the topology where is the problem and prepare a plan not only for remediation, but also to act before the problem is detected. Example is on a balance of the interface internal in a port channel. This feature is very useful because it allows us to aggregate interface and create a channel of a high-speed interconnection between the source and the destination, and also could be useful if one of the two interfaces is not working as expected. But if for any reason one interface is using always more than the other one, it can create problems in the interconnection and in the reliability between the different links. We move to the platform, and we can see that here we have a specific check based to the interconnection of the port channel. If we click and go to the drill down, we can see that we have the detail of all the members present in our port channels, and the name and also the list of the port that is present in this channel. Here we can highlight if for any reason one of the ports present in the channel can have some problem, and so maybe the ratio and the difference balancing between the one inbound and the other usage of the interface could be different. If we move to this other table, we can see that is represented also the balancing ratio and the variance. In this example is very high speed because we don't have traffic in this moment, but we can use an example on the customer side that we can see that the warned interfaces is the one where we have a ratio that is completely different between one interface and the other one. If we move back to the platform, we can see that it's always possible to see also the interface in the specific topology, and moving and seeing the detail on this specific topology. We can select the interface about the port channel and highlight where the variance is not expected, and the member status, for example, is not behaving as we expect. Again, here it's possible to highlight a specific detail and activate directly on the interface that is marked as down. In the next example, we will see how IP Fabric can support us in the visibility of BGP protocol. The BGP routing protocol is one of the famous protocols used at internet level to do the interconnection at service provider level, but is also used to some internal network with the provided the interconnection to the internet. And because of the way of the information are exchanged between the different routers with the BGP, we exchange all the route that can connect one IP address to all the other one in the network. And this configuration can guarantee that the BGP is very flexible routing protocol and can be adapted to all the failure or changes that are present in the network. One of the best practice of the configuration of BGP protocol is to install at least two links between the internal network and the service provider network. And in this way, we can ensure the redundancy between one link and the other one. The checks that are present in IP Fabric can allow us to keep an eye on the configuration of those two links and to receive an alert if one malfunctioning of one of the two links can compromise the resilience of this specific feature. And we can connect to the platform and see in the detail how this happens. Here in the dashboard we can have several checks and also several checks related to the stability of the routing protocol. But in this case, we would like to focus on one specific test that we have about the BGP received prefix. The information that are exchanged between the router and the service provider and the internal network contain also always an information about the prefix that is exchanged between one part and the other. And the number of this prefix has to be the same on the internal router and on the service provider side. In this way, the reachability of the network is configured and performed very well, and we can always say that the link is resilient and we can perform a very good connection between one and the other one. If we click here on the filter, we can go directly to the list of the BGP neighbor table, and we can have a look on which sessions are established and where the protocol exchange correctly the prefix. Those numbers could be different, but the important thing is that it's the same on the internal side and the external side. So in all these cases, we can guarantee that the resiliency is guaranteed, and we can accomplish the complete and full visibility in the network. But here, if we change the filter and we click on the other option, we can see that there are also some states where the connection is established, but the number of the prefix exchanged is 0. So there is probably a problem on the service provider network that is not sending us the information about the prefix that are exchanged. In this case, we cannot count in the resilience of this specific link between the provider interconnection and the internal interconnection. Here from the table on IP Fabric, we can also see the visibility on the topology, and if we click here, we can drill down and expand one specific site. And we have already the visibility of the internal and external BGP exchanges. Again, here we have the list of the check, and we can have a look on which devices have some problem in the interconnection. And here, for example, we can drill down and see the detail if there is some problem in this specific interconnection where the established the connection but is missing some information in the received prefix. In this way, if the other link that is established between the provider and the router is encountering any kind of problem, we cannot guarantee that the other one has the same information and providing the routing properly to the external part. In this case, the monitoring tool that we are using to track the network and to track the status of the network cannot receive any alert because the BGP session is established and the link is always on and maintained by the first link between the internal and external part. So in this case, it's not possible to recognize any problem in the BGP interconnection until the main connection will go down and the secondary one is not established and is not working fine. This kind of problem can create a big block in the internet connectivity, and having a tool that underline and overview this kind of information can help to reduce the problem, but also to prevent the problem before a failure occurring in all the entire network. In this last example, we will see how the resiliency is also connected to the security. We say that the network has to react to some inconvenience that encountering the everyday working, but we have to be sure that the security is not affected by those changes. So it's not a problem to giving access to one specific area where there are the sensitive data in our infrastructure. With the massive usage of the remote working and also the new technology bring it inside of the network, like bringing your devices, the difference in the security of the network is very high. So before we are used to have a perimeter that was regulated by the firewall to allow the access from internal to external part of the network, or also regulated the access internally in the network. But now with this new technology, the perimeter is much more hybrid and is very different, and is moved to the security layer at the edge of the network to something that is very restricted to the port connection to each single device. The most famous and used protocol for the LAN security is based on the protocol 802.1x, and that allows the permission to the visibility of the network after an authentication and after recognize the profile of the specific device. And this is very important to be sure that the access to the area of the network is regulated and is not widespread to all over the port and the configuration. This kind of project requires a lot of time in the design and is quite complex, the implementation, because it's necessary to have an up-to-date status of the configuration of each port and maintain this information updated every single day, and every time is changing the configuration. So the design phase normally is initiated to configure a port and put it in a monitor state, where it's possible to learn how is the device that is connected and to give the access to the different network based on the profile of the device. In this first monitor phase, the access is guaranteed to all the resources of the network. And then, when the port is recognized and the device is recognized and connected to the port, it's possible to move to another level of the project and assign to the port the authorization or not based on the profile. Both steps need a lot of documentation and need to have a very detailed information for each step. So we move to the platform, and we can see that in IP Fabric we can have several status of, we can trace the several status of this specific project. Here on the dashboard, where we have all the list of our check, we have one specific test that is based on edge port security that allow us to have an overview on the edge port and which is the method that is configured in this specific port. If we click here on the list of the port, we can have a drill down on all the port where is configured or not configured the security method. In this case, in our lab, we can see that are not configured any kind of protection, but we can move to one environment where we have several parts, and we can see that the focus on the port where the security is implemented is only on the edge one. On the other one, we can have the configuration or not, but we can keep this information just as a warning and not alert in the platform. The information that we connect here in the platform is also available here on the topology part. So if we click and enter to the topology part, we can see that here in the list of the check, we can have an overview again of the different port and the different configuration. And for each single device, we can have the detail on what is the port and what is the status, if you are in monitor, if you are in access, and if the configuration is configured or not, and the protocol is applied or not yet. And all this kind of documentation is always available at every snapshot and every time that we complete a discovery on the network. So tracking this very important information is very supportive in the part of maintaining the information updated and managing the different protocol and the different implementation of the protocol in our network. In these times, when we expect that the algorithm find a solution for us, it's very easy to think that everything is handled automatically without us having problem to configure and worried about what is the state of our devices in the network. In the example that we have seen, the network was responding very positively to preventing the problem in the usage and was acting resiliently to the impactful situation. However, it's not happened without constant planning and checking of the state of the configuration that we have in the infrastructure. We have seen that IP Fabric can help us in the design and in the governance of our infrastructure by providing a snapshot of the configuration that we have made and giving us an up-to-date visibility of all the anomalies that can be possible in the network. I hope that you found this information useful and to know a few more features about IP Fabric. And I hope to see you in the next episode of Tech Fabric. Thank you all.